Consider a large population, such as the population of Australia. A proportion of this population will have a particular trait. Let's say, for example, left-handedness. Whether any particular individual shows a particular trait is a Bernoulli trial. People are either left or right-handed, and yes, some people are ambidextrous, but even so, they would have a preferred hand. If we take a sample which is small in comparison to the population, the probabilities will change by such a small amount that we could consider the number of individuals in the sample that show the trait to be binomial. Now, let's just have a word on this. Let's just say, for argument, that the population of Australia is 20 million. I know it's a bit more than that, but it's a nice round number. And let's say that 2 million of those are left-handed. So the probability of the first person we pick being left-handed is 2 million out of 20 million. Now let's say the first person we pick was left-handed. That would leave us with this many left-handed people to choose from and this many members of the entire population to choose from. And these two numbers are very close together. So small a difference that we could, for these purposes, consider it to be the same. Therefore, since a binomial is a series of Bernoulli trials, we could say here that we're dealing with a binomial with n people in the trials and the probability of success being p. So, let x be the number of individuals in a sample that show the trait. The expectation of x, as we know from this distribution, is n times p. So if we consider the sample proportion, i.e. the number of individuals who show the trait divided by the number in the sample, that is np divided by n, and therefore the expectation of p is p. In the same way, the variance of x for a binomial we know is npq. Now remember, variance is a squared quantity. So what we would need to do for the variance is divide by n squared when we're looking at a sample proportion. So we can cancel an n from the top and the bottom, and we end up with pq over n, where q is a way of representing 1 minus p. Therefore, the standard deviation, being the square root of the variance, is the square root of pq over n, or if we replace q with 1 minus p, the square root of p times 1 minus p divided by n.